So today we're going to learn how to solve triangles using the law of sines. And using the law of sines, we use sine of angle A over variable A equals sine of angle B over variable B, and sine of angle C over variable C, or pretty much any other combination, meaning I can do A over A equals C over C, or A over A equals B over B, B over C, whatever matters, depending on the problem. So let's just start with an example. Sine of 15 over 5 is sine of A over A. And sine of 30 is over b. And to find b, we need to set up a cross multiplication equation. So sine of 15 over 5 equals sine of 30 over b. We would have to do 5 times sine of 30 divided by sine of 15. So 5 times sine of 30 is 2.5, and dividing it by sine of 15 equals b, and b equals 9.7. So to put that in a real-world problem, we're going to go on to a equation. A vertical flagpole stands beside a road that slopes at an angle of 15 degrees. When the angle of elevation of the sun is at 62 degrees and the flagpole casts a 16-foot shadow, we need to find the height of the flagpole. So the flagpole is illustrated here, but the first issue is we need to find this hidden angle of A, so that way we can find the height of the flagpole. So, by this, triangles come together at 180 degrees. Since we have two angles at 105 and at 28 degrees, we add them together to get 133 degrees. So 180 minus 133 degrees is 47 degrees, which is the hidden angle of A. So using this, we are going to put it into the original law of sines equation. So it would be sine of A over A is sine of 47 degrees over A, and we don't know that yet. And then we can use pretty much any other, angle and feet representation, so we're just going to use B. So then sine of 47 degrees over variable A equals sine of 28 over 16. So then, using cross multiplication, we see that we can do this. So 16 sine of 47 equals 1.98 using a graphing calculator. And to get A, we need to divide by this extra variable right here. So 1.98 divided by sine of 28 equals A, which is our height of the flagpole. And A comes out to 7.3 feet. And that's the answer to our problem. 7.3 is the height of the flagpole. So going on to another
I need evidence of action.
So in this problem, two observers are 600 feet across on opposite sides of the flagpole. The angle of elevation from the observers to the top of the pole are 19 degrees and 21 degrees. So we're supposed to find the height of the flagpole, which is illustrated by the line A. So we know that we need to find this hidden angle of A, so we do the usual 180 triangle minus 19, this angle, and minus 20, this angle, to get 140 as angle A. So to set up a proportion, we can do 140 over the line A, 600, equals sine of 19 degrees over B. And B would be, we need to find this line. So we would do cross multiplication. It would be 600 sine of 19 equals 195.34 divided by 140 equals B. And B equals 303.9 feet. Now, moving down, we can create a new triangle in a simpler problem. So now we have 20 degrees from up here, 303.9 degrees from B, and X, which we don't know is the height of the flagpole. So, creating a proportion, we can do sine of 20 degrees, which we know, equals X, the height of the flagpole, divided by B. 303.9 sine of 21 equals X, and X equals 108.9, the height of the flagpole.
In law of sines, it applies to many everyday life activities such as looking at a hot air balloon. So in this example, two observers 2.32 miles apart see a hot air balloon directly between them, but at the angles of elevation shown. So obviously, observer A is 28 degrees and observer B is 37 degrees. Find the altitude of the balloon. Another word for altitude is height, so like I said, if you ever want to look at the height of a balloon in real life, this is what you do. So first, to get this angle, we have to add 28 and 37. 2837 equals 65. We're going to subtract that from 180 because every triangle has 180 degrees, and we have 115. Now with that, we have a sine proportion. So right here, we're going to write sine of 115, the degrees, over 2.32 miles. And we're going to do that with either sine of 28 or sine of 37. Preferably I use the one on the left just because it's easier for me. And we're going to be looking for, we're going to look for A. Obviously we're going to cross multiply. And with that, we're going to get x equals 1.61. Go. Another example is a 4-foot airfoil attached to the cab of a truck reduces wind resistance. If the angle between the airfoil and the cab top is 18 degrees and angle B is 10 degrees, find the length of the vertical brace positioned as shown in the figure. So as you can see, the airfoil is colored in red and the brace is in black. Now, to get this problem, we have to before we break it down into smaller triangles, we have to look at it as a big triangle. So, as we know, it's formed a 90-degree angle. And what's given is 10 degrees and 18 degrees. So first, we're going to combine 18 degrees and 10 degrees to get 28 degrees. And we know from this problem that there's 90 degrees, so we're going to add 90. And with that, we're going to subtract it from 180. And we're going to get 62 degrees. Now, with that, now we know that this angle is 62 degrees. Now with that, we're going to put our sine proportion, because we know that's 90 degrees. That corresponds. And we can choose, since we're looking for the height, we're going to choose this angle, which is 62 degrees. So sine of 62, and that should be over x, the height that we're looking for. And once you do that out, you should get x to equal 1.2 feet in height. So if you're ever standing on opposite sides of the tree with your best friend and want to know the height of the tree, this problem's for you. Two observers are 400 feet apart on opposite sides of a tree. The angles of elevation from the observers to the top of the tree are 15 degrees and 20 degrees. Find the height of the tree. So we know that this elevation is 15 degrees and 20 degrees. First step we're going to do is add the two together, 15 plus 20 equals 35, to get what we need to find. So we know that every triangle has 180 degrees, so we're going to subtract the total of these two to get the remaining angle, which is 145. Now, with that angle that we found, we're going to set a sine proportion. So sine of 145, this angle, corresponds with 400 feet, this one. And with that, like I said, you can choose either the left or the right one. And this time, and preferably, as I said before, I like to choose the left side. So the left side is 15 degrees. So I'm going to write sine of 15 degrees over x to find the remaining side. And with that, I got 180.5 feet. Now with that answer, as I know, I broke this triangle in half so that I can get the height of it, because it doesn't matter if I broke it in half or did anything with it when it comes to height. So I know that this is 90 degrees because when you split a triangle like this in the middle, it forms a 90-degree angle. Okay, so with that corresponding one, we know that this x is 180.5, so we know that these are proportional to each other. So sine of 90 degrees over 180.5 feet And this time I have to use sine of 20 to get my answer, because sine of 20 corresponds with the height. So sine of 20 over, we're going to use h for height. And once I cross multiply, I got my height to be 61.7 feet as my answer.